Hey there everyone, my name is Chantel, and welcome to another AllDeck video. And in this video, I'm going to be going over simulating and debugging a Xilinx Vivado project using Riviera-PRO as the simulator. While Vivado may have its own simulator, AllDeck's Riviera-PRO easily integrates with Vivado and provides users with a more verbose and fast-performing simulator and debugger environment. And for this video, I'll be using Riviera-PRO 2024.10 and Vivado 2024.2. Now, in order for Riviera-PRO to work with Vivado, two things must be done prior. One is to make sure that the path to the Riviera-PRO installation directory is set. Do this by going to Settings under Tools, and then go to Third-Party Simulators, and make sure the path is correct for Riviera-PRO in the install paths. The second thing is to make sure that the proper Xilinx Vivado libraries have been downloaded and compiled into Riviera-PRO. If you need to do this, go to Compile Simulation Libraries, located under Tools. For information on that, I've linked AllDeck's application note on compiling Xilinx Vivado simulation libraries for Riviera-PRO in the description below. Once that's done, it's now time to open up a Vivado project. I already have an example file I'll be using called BFT example, which actually comes from one of Vivado's example projects. You can find this by going to Open Example Project, click Next, look for BFT, and go through the rest of the project creation process. Now I'll click on My Design to open it. Once opened, we'll be in the Project Manager, and we can see its sources. This example project even has a test bench, which I'll be using for simulation. In order to be able to simulate this test bench in Riviera-PRO, go to Settings, located within the Flow Navigator pane of the project. From there, go to the Simulation category, and change the target simulator to Riviera-PRO. Notice how the tab settings below have changed after setting the simulator to Riviera-PRO. From here, you can change a number of options, including compilation and simulation settings. You can click on each option to see a brief description of what they do. In the Compilation tab, you can select options for compilation that you can normally access within Riviera-PRO. For this video, to demonstrate simulation and debugging, under the compilation settings, I'm going to check Debug. This will allow me to step through the project code and utilize breakpoints and the data flow window during simulation. I'll also be checking the statement and branch coverage options to demonstrate that it is possible to gather coverage data from a Vivado project. Under Simulation, you can change things such as the simulation runtime duration, as well as even setting a user-made macro. I'll also have debug checked here, as well as logging all the signals for the simulation database. And in order for coverage to successfully generate, I'm going to check the respective statement and branch coverage boxes like I did in the compilation settings. After adjusting these settings, click Apply, and then OK. Now we can run a simulation. In the Flow Navigator pane under Simulation, click on Run Simulation, and then click on Run Behavioral Simulation. From here, Vivado will execute the analysis and compilation step, which will then cause Riviera-PRO to launch and open up the project. And once loaded, the simulation results will appear in Riviera-PRO's Waveform View window. Now the Vivado project has access to the debugging options Riviera-PRO has to offer during simulation. And to get the most out of debugging, I'm going to switch over to the debug perspective. Here inside the Waveform Viewer window, you can do things like sorting your signals and grouping your signals by creating a named row and moving them, or by creating a virtual group. During your simulation, you can browse different types of events across many signals, like browsing by rising edges, falling edges, and more. You can also set bookmarks, where you can specify if it's for a particular signal, and even give it a comment. There is also a tool that allows you to add multiple cursors so you can mark your waveform at different points in simulation time to see the signal values at that marked point. So these are just some of the things you can do for debugging your simulation waveform in the waveform window. There's also other different debugging windows, like the watch window. You can use this window to monitor other signals outside of the test bench signals you see in the waveform. From either the hierarchy window or objects window, just click and drag signals you want to watch and continue to run through your simulation to view the results. And as you can see, there are plenty of other windows you can use to monitor different aspects of your simulation, like the call stack, locals, assertions, and covers windows. Right above this area of debugging windows is the objects window, and the tab that shares this window area is the drivers and readers tab. This is where you can place a signal from your design and see the other signals that either drive it or read from it. And if you'd like to see a visual depiction of how these signals are connected, with debug enabled, you can go to the data flow window and then drag the design into it. From there, you can double-click on different parts of the design to expand it and see how the design signals are connected. When I run the simulation for another 100 nanoseconds, you can see that the data flow window also updates the values of the changing signals. Another perk of debug being enabled is the ability to set breakpoints. You can see on the top left-hand side of the screen that there are many different types of breakpoints. You can right-click on a signal in the Objects or Waveform window and set a signal breakpoint. Or in the Hierarchy window, you can double-click on a design object, like a round 1, and double-click on a line within this gray column to set an HDL breakpoint. Again, there are more types of breakpoints you can utilize than just these two. I'll go and delete these breakpoints now, and I'm gonna go back to the waveform viewer and set an event signal breakpoint for error. Remember from earlier in Vivado, I selected the compilation and simulation options for code coverage, specifically branch and statement coverage. Now I'll run the simulation until it stops at the breakpoint, and I'm going to show that you could see some code coverage in the HDL editor, and I'll also generate a coverage report. If I go to the hierarchy window and double-click, let's say, a round 1 again, I'll be taken to the HDL editor window for the VHDL BFT code. Notice that on the left side, there are a couple of columns labeled branch and statement coverage. To get these to appear, you'll need to click on this chevron icon, right-click within this measurement bar, hover over coverage, and select the desired coverages you want to see information about. In the columns, you'll see an icon of either a green checkmark or a red X, along with a green or red highlighted line of code to indicate if the branch or statement was 100% covered. There's also a numerical value indicating how many times the line of code occurred during simulation. Now let's generate a report for this coverage. This can be generated as either plain text or HTML format. For this demonstration, I'll be doing HTML. All I have to do is use the acdb report command, which I'll type in the console. I'll then type -html, then -o to name my output file sim1.html. I'll hit enter, and I should now have my ACDB coverage report. When I go back to the default perspective and go to File System, I can double-click on it to open the report in Riviera-PRO. Here, you can access and see all the coverage statistics and details. And there you have it. We were able to simulate and debug a Vivado project through Riviera-PRO and use its many tools to gather lots of information on the design just from simulation. Being able to use Riviera-PRO's simulator makes simulation and debugging of Vivado projects faster and more comprehensive. Thank you for watching.